If you're tired of manually provisioning and managing your infrastructure, you need to check out Terraform. It's a powerful deployment tool that lets you control your infrastructure as code, whether it's cloud based or not. But why should you even bother with infrastructure as code? Well, for starters, it helps you avoid the headache of manual deployment. By managing your infrastructure with code, you open the door to automation and can enjoy a release oriented approach similar to how you handle application code. In this tutorial, I will walk you through each step of using Terraform to provision an AWS EC2 instance so you can experience the benefits of IAC firsthand. Deploying software is like trying to put together a puzzle blindfolded on a Friday night after a long week at work. But fear not, because Terraform is here to save the day. It's like the superhero of infrastructure provisioning, making everything consistent and repeatable across all your cloud platforms, whether they are public, private, or somewhere in between. Basically, Terraform lets you use fancy human readable code to define your infrastructure, and then with just one simple command, bam, it deploys everything for you. No more hair pulling, no more Friday night disasters. Just sit back, relax, and let Terraform do the heavy lifting. So you might be wondering, but how does Terraform work with all these different platforms? Is it like a wizard with magic powers? Well, not quite, but it does have a secret weapon: Terraform providers. Think of providers as little helpers, kind of like minions that talk to the external APIs and take care of all the nitty-gritty details for Terraform. They are written in Golang and easily available through the Terraform registry. These providers act as the middlemen between Terraform and the platform, handling everything from authentication to making API requests, even managing timeouts and errors. It's like having a personal assistant for your infrastructure. Each cloud vendor maintains its own Terraform provider, and at this point, there are hundreds of published providers available on the Terraform registry. You can also write your own Terraform provider. This is what we are going to create. We are going to write a Terraform configuration file and pass it onto Terraform that will in turn create the EC2 instance for us. In step 1, you need to create a directory for the project files. Within the directory, create the main.tf file to write the initial Terraform configuration. In case you are wondering, the configuration is written using a language known as HCL or HashiCorp configuration language. The language is human readable, even more than JSON, and forms the core of Terraform. The code itself is simple enough to understand, but let's go through it step by step. The first block configures the provider. Providers only have one label, name. This should be the official name of the provider as published in the Terraform registry. In our example, the value is AWS for AWS provider. The AWS provider is responsible for understanding API interactions and making authenticated requests. You need to configure a provider by passing some inputs to the provider block. As an example, set the region to US West 2. Also, direct the provider to use the profile for Terraform user. Since AWS APIs need authentication, you will have to create an IAM user, generate credentials from the AWS console, and set those credentials with your local system's AWS CLI. For this demo, Terraform user is the IAM user I have created to manage our Terraform resources. If you want more information on setting the AWS credentials, I have provided the link in the description below. Let's now move on to the next block in the main.tf file, the star of the show, the EC2 instance. This EC2 code block is an example of a Terraform resource, and let me tell you, resources are the real MVPs of Terraform. They are the ones in charge of actually provisioning the infrastructure. A resource block has two labels. The first label specifies the type of the resource, and the second is the name of the resource. In this example, the type is AWS Instance and the name is Hello AWS. The name is just for reference within the module scope and has no special significance. However, the type and name together make a unique resource identifier. Each resource takes some inputs. In this case, the inputs are the AMI ID, which is the image used to create the EC2 instance. In this case, it's the Amazon Linux image. The instance type, which is the size of the instance. I recommend using the T2 micro instance that is available in the free tier. Tags, which are special key value properties you may want to associate with the instance. And the resource also has some outputs that are generated after Terraform has provisioned the necessary infrastructure. In fact, the input arguments also end up as output attributes. However, Terraform also attaches new output attributes such as the ID of the created resource. So you can see that resources are truly the backbone of Terraform and you can't go wrong with them. Now before Terraform can get to work and deploy our EC2 instance, we need to do a little setup first. It's like getting your tools ready before starting a project. What we need to do is download and install the AWS provider binary from the Terraform registry. Think of it as a special helper that tells Terraform how to talk to the AWS API. And this step is required at least once for every workspace. To get this party started, all you have to do is run the command terraform init. Your workspace is now initialized and ready for Terraform to do its magic. You should see an output like this. So what's going on over here? Basically, Terraform gets to work and fetches the latest version of the AWS provider and installs it in the workspace. You will notice that a new folder named .terraform appears in your workspace. This is where the downloaded binary for the AWS provider is stored. And to keep track of everything, Terraform also creates a log file named terraform log.html, which records the provider selections. It's a good idea to include this file in your version control repository. That way, when you run Terraform init, in the future, Terraform will use the same selections by default. It's like a safety net for your infrastructure. With the initialization done and dusted, we can finally get to the good stuff and deploy the EC2 instance using Terraform. This is as simple as running the command terraform apply and answering yes to the confirmation prompt. And before you know it, you will see some output that tells you the provisioning is complete. It's like magic, just with a bit more code involved. And with that, you're all set and ready to use your new EC2 instance. And don't forget, you can always check the new instance in the AWS console to see it in all its glory. Just as a reminder, the instance is created in the US West 2A region as specified in the Terraform configuration file. And now, you might also notice a new file named terraform.tf-state that's been created in your project directory. This file is like a diary for Terraform. It's a JSON file that describes all the resources that Terraform is managing. And if you want to take a peek at the contents of the file, you can use the command terraform show and it will show you the information in a more human readable format. It's like a behind the scenes look at what Terraform is doing to keep your infrastructure in check. Just as easily as Terraform created your infrastructure, it can also tear it down. It's like a demolition crew but for your cloud infrastructure. All you have to do is run the command terraform destroy and it will prompt you for confirmation. And if you say yes, Terraform will go ahead and destroy the EC2 instance that we created in the previous section. It is a good idea to do this if you don't need the infrastructure to continue running and you want to save on cost. But remember, destroying infrastructure managed by Terraform is irreversible, so think it through before you proceed. And that's a wrap. We have successfully used Terraform to deploy an EC2 instance, and if you want to give it a try yourself, the code for this project is available on GitHub. You can find the link in the video's description. If you found this video helpful, please share it with your friends and colleagues. And don't forget to hit that subscribe button so you don't miss any future videos. And also don't forget to press the bell icon so you get instant notifications when new videos are out. Thanks for watching and I'll see you in the next one.